So rough intended aesthetic is I screw around with doing research and attempt to narrate my thought process, and you guys just jump in regularly whenever you have questions. And empirically, in the periods where people are afraid of looking dumb and not asking questions, I get way more insecure and find this way less fun than when people are constantly asking questions. So I actively prefer you to towards asking questions. Anyway, so high-level goal. A thing which seems to be a really common pattern in people doing IOI-style mechinterp is that models have these things that I call mover heads, which produce something like the output name. And the way they do this is by looking at some earlier word in the sentence, predicting that that word comes next, and using their OV circuit to like directly map the embedding or like things which transform the embedding in predictable ways to the output on it. And this just seems like a thing that happens a bunch. Like IOI has name movers, the forthcoming DeepMind paper on multiple choice questions has correct letter mover heads. Induction heads are arguably mover heads. The Python doctoring circuit Stefan and Jet found has parameter mover heads. There's a bunch of random ass remix things that have like various other kinds of mover heads. And I'm just like, this seems like a really generic thing. And a beef that I have with like IOI style stuff is that it's kind of just narrow. Like it studies things on things like the IOI distribution. Stuff looks monosemantic because even if it's polysemantic, all of the other stuff is like not on the distribution, and this is annoying. And this is kind of cheating. And a thing which is very interesting to me is like, can we even say coherent things about something on the full data distribution? And I would like weakly argue that Wes's French neuron is like a thing that actually has some coherent meaning on at least like a reasonably broad data distribution of like, is French and it's not French. And this would be a way more evocative way to make a point if it didn't take ages to load because Wes has too many pictures. But like, as far as I'm aware, no one has just actually checked things like, are the name movers in IOI like meaningful on the full data distribution or not? My guess is that they are not name movers because IOI is a ridiculously niche task. Though it would not surprise me if there's some weird ass superposition going on where like that set of like 7 heads working together and looking at the same thing only occurs in an IOI-like context. But I have the like weak take that this motif of like heads which copy whatever they look at and directly map that to the output with like all of the interesting computation being their attention patterns might just be a thing that is actually a thing on the full data distribution, even if it moves a bunch of stuff. And I want to go figure this out. How much sense does that make?
Makes a lot of sense. Makes me wonder if some sort of move ahead detector would be something to add. Which also leads to a question. You said that it uses the OV circuit to directly map the embedding to the output. How do you know that? Is there causal patching to determine that it's actually moving from the embeddings directly to the output, do not pass go?
So 2 things. First off, models seem to do a bunch of boring shit of the form have early layers that just transform the embedding. Like MLP0 in GPT-2 small seems to like literally be a like embedding transformation. In Pythia, it's even more boring, where like MLP0 literally cannot see anything that is not the current token because Pythia has attention at MLPs acting in parallel, which means there's no attention feeding into the MLP0. So it is literally an embedding. The way you would test this if you actually had a name mover head is you could be like, I'm going to load in GPT-2 small and give it an IOI-like prompt and look at the like name movers and then be like, let's see, run cache. Let's say the prompts are like, when Alex and Tim went to the store, Alex gave the bag to. A fun fact about IOI John and Mary, is that the final layer norm bias boosts the John logit by like 1 relative to the Mary logit. And you also get like random biblical and nativity stuff kind of thrown in because models are fucking cuts, which is the motto of Macintosh. Anyway, yeah. So if I take this and yeah, and then be like model.run with cache. And then just like try to actually look at, let's see, do I have a direct logic attribution function? I might have a direct logic attribution. I think someone added this or something. Nope, that's sad. Oh, they have a logit attribute function. That's exciting. All right, let's see if this one works. So this function, which gets me the decomposition of the residual stream into embed, pos-embed, bias, or MLP outputs, and like each head output, I can. Oh wait, what just happened? I can then print the shape to check that it's what I think it is. Take this. I feel like the most educational thing about this will be how shite my coding practices are. And since I have 2 software engineers in the audience, they can go and be obnoxious and correct me on things. Okay, great. What the hell happened?
We did do a bit of a cleaning up of the exploratory analysis prompt code, which we should probably actually add to the demo at some point.
I think Callum wrote a IOI style tutorial, which I have not actually read, but I'm just going to assume is strictly better than what I did. And should
well, you did have yours to build off.
Yeah, exactly. So it'd be very embarrassing that it's not strictly better than what I did. I think he also added in a implementation of path patching, which is great. Someone should really add path patching to transform the lens properly. Oh wait, I should like actually be running the lines of code that I'm writing. That's a useful thing that people should do. And yeah. So component batch. I think pos doesn't exist. Model, this is just the model. And what? No, not what I want. Yeah, this, I believe, is going to be something vaguely coherent. Oh no, why is this sad? Oh, why did that happen? Yes. Audience is calling out dumb results. It's extremely welcome. Beautiful. The heads which I think matter actually matter. And then there's some heads which are massively negative for some fucking reason that I sure would love if someone could figure out.
Why did you think those heads mattered?
Sorry, there are heads which have high direct logit attribution on the logit difference and high negative direct logit attribution on like the other one.
Yep.
Which color is the good color? Like clearly there's like a mirror because one of them is Alex and one of them is Tim, but which one do we actually want?
Let's
Like if
call
it's
this.
the red one that's on top, does that mean it's a positive head or a negative?
Oh wait, shit! You make a good point. It's actually the wrong way around, and the first one should be negative, and the second one should be positive because I'm dumb. Yeah, should be negative. Is in fact negative. Life is good. All right. So let's take heads 9.9 and just take.
So why aren't they actually the same? Like 9.9 is like +3 for Alex versus Tim, but like -4 for Tim versus Alex. Shouldn't they be identical but reversed?
Yeah, models, man. Yeah, I got nothing.
This feels less like a model thing and more like a math thing. Like if A minus T should be minus T minus A. I wonder if there's a mistake
sorry.
we've made here.
So blue line is on the prompt Alex gave the bag to. Red line is the prompt Tim gave the bag to.
Oh, so we would expect it to be in reverse, but it's not mathematically guaranteed, and the things we expect do not always happen because models are cursed.
Yeah, exactly. You're getting the Mechanterp workflow down. Anyway.
And what's the idea behind those later heads that have colors flipped? They predict the wrong thing, right?
Sorry, do you mean this head or this head?
Yeah, that one. Layer 10 head 8, I think. Yeah, this one.
Oh, yes. This is a negative name user head. I have no idea why these things exist, but they sure do exist.
Someone suggested it could be hedging the results, so if you're wrong, you don't get a huge loss.
Well, so that's sus, because if that happens, the obvious way of dealing with that is like words. Do I have again?
Like reducing the original magnitude of the first head.
Isn't the loss set up such that like giving your best guess gives you the best score anyway? I mean, if it's not, that's a pretty bad loss function. Like if you think there's an 85% chance if something is true, guessing 85% should be the way to minimize your cross entropy loss, right?
There's no reason to hedge in a single component as opposed to like reducing the effect of the first component. Could you be hedging based on some other information?
So I guess the way I would think about it is that I was just observing there is a nice function I wrote a while ago that I should really have actually saved someone to get, but didn't. And I don't know, I used to have a persistent dev box, and I was like, wait, it's really stupid to be paying thousands of dollars for this per month, but I don't use it a lot. And now I don't. And it's very annoying. So I need to set things up again every time I want to do these. Or use a collab, which is Cassier's own special one. And yes. So I'm instead going to experiment with actually having a coherent thing called a utility, which apparently I used to have and then got pulled off. All right. Let me see if this is a coherent line of text that will actually work. Did this work? I'm currently trying to make a function that will take a list of tokens and give me a nice thing, which is beautifully formatted. Oh, wait. It has a name. Oh. So all right, this is stupid. I will just copy this into my code and accept terrible coding practices. The thing which I'm trying to make is a function which can take a list of tokens and give me something that's like actually human readable and can be put into Plotly.
I think you need an extra bit of logic under as instance tensor to handle multi-dimensional tensors.
Yeah, s equals s dot item only works if it's a single value tensor.
Yes. The attempted strategy is that no one does this on things that are not a float, not a single element. Possibly I should add something, which is like assert this, but also it'll raise an error, so who cares?
Could have just put like s equals s dot item for s intensor or something like a list comprehension to actually handle that case too.
Yeah, so the idea is this is a process single token function, and this is like a thing that maps over a list or a tensor. And this is something that does that, but also has the index at the end. And Plotly is fucking cursed and makes it so that if you give it something on the like x and y axis, that Plotly makes it so if you give it something on the x and y axis that has duplicates, it will merge them because.
Why?
So I think it's like designed to get something that's like a list of like actual like X value things. And so it's like, I should superimpose these. And it just treats lists stupidly, which is why I just have a slash followed by the actual index. And also why I have things, code that replaces spaces with dots. Sorry, that's unrelated. I just like having things that are actually readable. And whether it has a space prepended is kind of important. Great, so the name mover does indeed look at the correct name. It also looks at it with like notably different strength, which is surprising.
There's a typo. There's two
What?
wins. One of them should be wins.
Good point, well made. Maybe it doesn't matter, who knows?
Might not. It's in both of them.
Anyway, so now the thing which I want to test is like Jay's original question of if we apply this to the like actual residual stream earlier on, what happens? And yeah, let's just do this to like position 4, and let's call this the Tim decompose resid. I'm not even going to apply a layer norm because who cares? And I want to test the hypothesis that if I take the unembed vector as why do I have code? Just so wordy.
I mean, you do have to get utils function, like a get act name function, right?
Yeah, the problem here is I want the weights. I do have a separate cursed thing where if you do model.w_v, it gets you a thing which is the stack of like every weight matrix across all of the layers. And this can kind of fuck over your GPU memory, but I probably shouldn't care because I'm at like 3 gigs. Anyway, whatever. And logit diff is Alex minus Tim. So let's just like negate that. And yeah. What I now want to do is like take the 0th thing of this, multiply by the unembed vector, and just like plot a line graph of this. Residual stream to unembed via layer 9 H9, and yeah, see what happens. Kill that sure really likes MLP0. Also is ridiculously large. Okay, so the problem is I failed to multiply by this thing. Or wait, I can never even remember if this is something I divide by or multiply by, though it's big, so probably I divide by it.
What are you trying to accomplish?
I want to apply the layer norm, because this is like 186, which is unnecessarily large. Anyway, actually no, I only cared about comparing things, and I'm like, well, it sure looks like the embedding is tiny and then MLP0 is enormous. Probably I should instead be doing this for like the Tim direction rather than the logit diff direction, because all right, if I do this for the Tim direction, then I see something which is like fairly coherent.
So what's this graph actually representing?
So the thing this is representing is if you take the output of every component of the model, multiply it by the OV matrix of the residual stream, multiplied by the OV matrix of the name mover head, and then just compose that with the output unembed. How much does this change the output logic?
And if the output logic changes by a lot, what does that imply about the underlying component?
It tells you that that component is telling the name mover you should output Tim. And under the hypothesis that mover heads just like copy whatever there is from what they're looking at, this kind of should tell you where the correct information is that's being copied. And my main observation from this is that, okay, MLP0 like massively dominates, but also a bunch of other stuff matters to a degree that I wouldn't quite have predicted. And I also screwed up and didn't tell it to decompose the residual stream at like layer 9, which means I got a bunch of crap I don't care about.
If activation patching seems to suggest like layer 9 is the thing that makes the big difference, why is it everything in layer 0 here? Or why are all the biggest numbers in layer 0 here?
Sorry, so the thing which is going on is that head L9H9 is attending from the final token to the Tim residual stream on like token position 4. And it's then taking this and saying, okay, I'm going to map this to the correct output. And this is, and I'm looking at the Tim residual stream, because if you fix the attention pattern of a head, then it's just mapping the residual stream via the OV circuit to the output. And the Tim residual stream is the sum of every component. It gets multiplied by the OV matrix, and then gets multiplied by the unembed to get you the actual Alex and Tim logits. If that makes sense?
A little bit. I'm still not really getting why the L9 values in the graph below just seem to not matter compared to the L0 ones.
Sorry. So like the value of L9H9 is like the resid at Tim at position 4 times WV of L9H9. Does that make sense?
Right. It makes sense, but this number is very low, which basically means that counterfactually, if you got rid of L9H9, it wouldn't make much of a difference, but it seems to...
No. Sorry. So what's going on is that I'm looking at the residual stream. I'm looking at this term, and I'm decomposing where this term comes from, and then I'm multiplying by this.
So L9H9 is using it, but L0 is the thing that most adds to it, and these MLP layers add to it over time, and then once it gets to L9, it's like, okay, it's time to use that now and actually move it to where it needs to go.
Exactly.
All right, now I understand.
I'm still confused. What's resid Tim pos for? Is that the Tim direction in the residual stream, and like at what layer? Where is it defined?
Layer 9.
Okay, cool.
For layer 9. That's this term. It's like, get the decomposition residual stream up to but not including layer 9.
Cool. So it's just the residual at the position 4 vector in the residual. Yeah.
Yes. This is also interesting because it's telling me that like these heads matter a bunch for producing it in a way that I would not have expected. I don't know. My prediction was that, oh wait, this thing matters a fuck ton. And then also, lol, the embedding just doesn't matter at all. Because MLP0 is just big.
I guess that would match the theory that MLP0 does a lot of the work that the embedding's supposed to do by like translating it into the model's native ontology, right?
Yeah, exactly. And yeah.
And that the attention head plays a big part of that?
Sorry, can you repeat the question?
There's attention heads on the last chart at layer 0. Yes.
This thing.
Do we know what might be going on in the layer 0 attention heads?
No. The obvious thing to do is to just like go and check. And so, I don't know. If I'm just like, let's get the pattern in like layer 0, and then, I don't know, just like take all of the heads and facet call 0 and just like plot this. Oh, wait. And I guess I only care about this up to residual stream 4. But What? Why is this insufficient? Oh wait. Yeah, so the heads that this claimed mattered were like, well, plausibly, some of these components just have a ridiculously high norm. And I probably just check. And it does indeed turn out that if you divide by the norm, then you get this thing, which
Much
is like
more
much more
sane.
flat. But also, like, who cares? Like, I care about the dot product, not like the normalized dot product. I was just mildly curious. So the thing we have here is just like, for each head, where is it attending? And we basically see, oh, lol, the 4 heads that seem to matter a lot, which I think were like 0, 1, 3, 1, 3, 4, 5. These are the heads which are strongly attending to the current thing. And I'm like, sure, that makes sense. I don't know why these attend to the current token, but they sure do. And I don't know, if I look at what they're doing on the full data distribution, it's like, nah, I got nothing. Anyways, this is all a massive tangent. And I probably returned to like actually planning out what research I wanted to do. I would like to claim that this tangent was for educational purposes, but also I just like tangents. All right, so returning to like how I'd actually plan out a project on this, which I'm probably going to spend this weekend hacking on because I don't actually have other commitments this weekend. Core question: are mover heads a real thing that is used on the full data distribution? So like 2 steps here are like 1, look at the full data distribution. 2, automatically check heads for how mover-y they are. And I don't massively care about being super rigorous or like looking at something across like many billions of tokens, but I do somewhat care about stuff like just running this over a bunch of data, trying to like see if I can make strong statements about like the way this head matters in general is by being mover-y.
Do you think like the
So-
file 10K would be enough data for this?
Probably, because I'm lazy. So question 1, what does mover-y mean? High direct logit attribution attends to copies of the next token. And maybe like composes with them. Or maybe like composes with embedding the things to map them to the output. Maybe let's make a fuzzier things category. That would be cute stretch goals, which are like composes with embedding things to map them to the outputs. What are other fuzzy things? Direct effect is all that it does. And it doesn't have significant other things that happen. Note, this is messy because everything is cursed. Specifically, you'll get calibration and amplification, where MLP layers upweight or downweight the head's contribution without doing real computation, I think. Yes, this just seems to be a general thing that occurs a bunch in models, and it's really obnoxious. Another fuzzy thing is like, does the head have a sharp attention pattern? Like, does it strongly attend and then predict a specific token? Or is it diffuse across many, or e.g. too many copies of the same token? I'm kind of categorizing all of these under like, well, these should maybe probably be instances of mover heads, but I'm also not super sure, and like, who cares? But ideally, I would check them if I have the time. Maybe is head superposition happening? I'll move these to just like stretch questions I'm curious about. So one hypothesis I have is that like heads are nowhere near monosemantic, but combinations of heads when they're doing approximately the same thing are monosemantic. And the model's doing some fucked up head superposition, and This is on my list of open problems I'm actually excited about someone working on. Another stretch question is like, if there are general mover heads, are these specific to any kind of now moving? Can we automatically detect them with weight-based analysis? Can we detect what kind of words it copies by analyzing the residual stream? By analyzing its OV matrix. The idea here would be like, plausibly, OV matrices are small in terms of rank. They can probably only capture so many words. And plausibly, you'll get things that are like really good at names and really bad verbs or some crap like that.
Could you explain the noun one more? Are these specific to any kind of noun moving?
Oh, sorry. Any kind of token moving.
Gotcha.
Names, days of the week, etc. Then there's like project setup questions. Garrett, be less of a perfectionist. Just get shit done. Move fast. Lol, I have weekends. Maybe I want a model I already know a bunch about. DVD moves more probably. Maybe attention only 4L because the docstring project happened. Then there's probably I want a model with heads that just directly compose with the output, which means attention only, or Python models that have parallel attention, because the final heads do not go via MLPs, they just go straight to the unembed, do not pass go.
Is that to make direct logic attribution simpler?
Yes. Or it's to make it so the direct logic attribution is like more faithful to what the head even does. Probably the thing I should do is just like, I want models with heads that just compose with the output, YOLO. And preference for smaller models, the obvious one to look at is Pythia 70M, because attention only 4L just seems a bit boring and specific because it's like attention only, so I'll feel less like I can make general statements. But also Pythia 70M is still pathetically tiny, even if Pythia is also annoying. And though I can just write code that will work for a bunch of models, who cares? If I'm doing Pythia 70M, the dataset should obviously be Pile 10K, though plausibly it'll be nice to go and dig into like actual Pile subsets later on, so I can be like, on the Europol distribution, it moves this kind of word or something. But like, whatever. I can figure it out. So, angle of attack, I don't know, dumbest thing to do would be run the model on a bunch of tokens, store the direct logic attribution of each head on every token. Also, I guess, store, I want to say store the attention pattern, but storing the attention pattern is kind of a headache because attention patterns are big. I also vaguely want to be doing the thing where I just store like a massive data set of the thing on the full like 10 million tokens rather than trying to split it up, rather than trying to get summary statistics. This guy hates summary statistics because they're evil.
What makes summary statistics evil?
I'd say they're evil because they get you to like, it's just really easy to be misled by them. A core principle of good mech-interp research to me is having the capacity to be surprised by what happens. And I think that if you want to be surprised by what happens, you need to be like actually looking at the raw data and like seeing if you're confusing yourself. And then you make summary statistics. Anyway, YOLO, I'll just put like inspect by hand the specific things that seem to happen, and then actually investigate whether heads are moving E. And probably the thing to do here is look at the pattern value. Wait, I should probably just check how high effort it is to like run Pythia over like a bunch of tokens. It's probably not that hard, and I'm over optimizing. All right, I'll just take my dumb line of attack for now as do this. store direct logic attribution, inspect the specific things that seem to be happening, and then figure out what to do next. And I have a bunch of ideas for like summary statistics I could use for like, is this head mover E? But probably I should just like get this data first and go and look by hand at a bunch of examples. So what do I want to do? I should rename this to IOI investigation. Make a new file for like Pythia direct logic attribution Sweden. So knowing me and my terrible coding practices, I'll probably turn this into something fuckier. Yeah. Looking at Pythia, set M, making my data set be file 10K. I think that should just work. Dealing with like a big list of strings is a pain in the ass because it's yeah, dealing with big strings is a pain in the ass because you want to keep the models tokens. Models have preference for like maximum token length, and it's stupid. This is a util which just takes the data set, converts everything to tokens, concatenates them separated by end of text tokens, and then just like reshapes. So it's like a massive block of the correct length. And this is just much easier to feed into the model. You don't need to stress about padding tokens or strings being truncated and crap like that.
Wish I knew about that last week.
It's really embarrassing. Hugging Face just like does not have a function for this, despite this being like an obvious core operation. And I spent like 2 hours combing through Hugging Face tokenizer documentation back when I was like trying to train my like interpret-friendly models until I was eventually just like, it's fucking dumb. I should just write my own. This is not that hard to write. I'm also just trying to build the habit of just like sucking it up and just doing the thing that's a bit tedious but will clearly get me the answer I want fast, because this just seems good and like a habit that I really want to get into. Because I have the bad habit of being like, well, I know the thing that I would obviously do if I had like actual willpower, but this is too much effort, so I'm not going to do it. And this is bad. Ooh, does this thing have a version of Python fancy enough I can use this motif? Ooh, it does. So exciting. Though, actually, if I want to publish this as a Colab notebook, I should probably not do that because Colab notebooks are stupid and have old Python.
What is that you just did that was different?
Oh, if you put an equal sign here, it will give you name of thing equals value of thing.
Ah, okay. Interesting. I didn't know that. That's cool. When did that come out?
Python 3 point something, bigger than 8.
Ah, yeah, that makes sense.
This is a really obnoxious thing where some Colab notebooks are like Python 3.7. This means that if you want something to work in them, you like can't use fancier new features, even though they're sometimes quite nice.
And that's why Transformer Lens supports 3.7.
Yes, that is why it supports 3.7.
Mystery solved.
Okay, what the fuck just happened? So I am very confused because pile tokens is 60,000 strings of length 1, which is not what this function is supposed to output. Wait, what?
Yeah, tokens
it's a data set. This makes sense now. So the thing that I'd forgotten is that tokenizing concatenate outputs a Hugging Face data set of tokens, and that if I do this, then I get something actually sensible and reasonable. And I made the length 256 because my hypothesis is that move aheads are often fairly local, and I don't want to have enormous attention patterns to need to care about.
Why do you hypothesize that they're local?
Name move aheads are local.
How do you know that?
By local, what I mean is it moves stuff nearby.
Yeah, I know what you mean by local. I just mean like, did they test that in the IOI paper? Did you test that at some point? Like, where was this information found, or is this something that was empirically tested, or something you think should be true
No.
intuitively?
Sorry, I'm literally making the stupid claim that like when IOI is happening, you're moving a name in the current sentence.
Mm-hmm.
And this is obviously
Okay.
nearby.
So you don't
And-
know if this is true. This is just a theory you have that you want to test.
Yeah. And
Okay.
like 256 is long enough that I should totally see long range moving and be like, fine. Anyway, what is the actual operation that I want to do? Probably I'll just take some reasonable batch size, like 32. Let's do this for like 0 to 256. With step size batch size. And no, I should just get a single batch of stuff. And run the model and define a like get head direct logic attribution function that takes into cache and does something. I kind of also want to write functions that are like get the max token, get the like argmax of like which is the biggest token. And I have some like crippling fear that I'm going to get ooms, like out of memory errors. And this is probably dumb because I don't have that many tokens. So I've got this times that's nothing. So what I want to do is store the direct logic attribution for each head. I want to store the argmax of the previously attended to token per head, and I want to get the argmax attention value.
What was the 1E9 before?
Oh, that's a billion.
But I mean, why are you dividing by a billion? That's what I'm asking.
Oh, I think in gigabytes.
Okay, right. So you're looking at how many gigabytes? So it's 0.7 gigabytes.
The fuck does that mean?
Yeah, I get it. I wasn't sure exactly where the 1E9
Yeah.
was going with that. I thought, is it megabytes? Is it gigabytes?
Oh yeah. Yeah, giga is 1 billion. These are very useful numbers to have memorized because my GPU will get sad. And for some reason, my cloud provider has issues with SSHing into like 80 gig A100s, and I've given up on figuring that one out. And 50 gig is
So like
sufficient.
us.
Man, I spent
Feels
like
somehow validating to have you be like, yeah, there's this thing I should do, which I would do if I had willpower, so I didn't. And also, there's this thing I would like to be able to do, but the technical issues have been too much, so I've just given up and I do without, because it's like, maybe there is hope for me yet.
This is what research skill looks like. It's prioritization. And prioritization means figuring out the stupid bullshit you don't bother doing.
Then I think I have a lot of promise.
I think the right way to think about it is weaponized laziness. Anyway. So yeah. So does cache have a stack function on it? Oh, it does. Go past me. I added this 4 months ago. Wild. So yes. All right. If I add type hints, do I magically? Yes, I get hop. Great. So yeah, this should be a stack of like all like mixed value vectors of heads, which I should really find like a better name for, but I'm just going to YOLO call Z because I couldn't think of a better name when I was writing the transformer lens code. Yeah, I want to get stack. It should have shape like layer by batch by pos by head by d head. Do I want to just create a like WOU matrix? So this is going to be like I'm probably prematurely optimizing. So the thing I'm trying to figure out here is like, should I create a matrix which is like the linear map from each head Z to the output tokens? Because this is probably a coherent thing to have. If that makes sense?
Yeah.
What? Stupid sort rolls. It's pathetic. What even is the number of layers? It's nothing. Yes. Very highly recommend using einsum for literally einops and einsum for literally everything. In case people have not yet heard the good word of einsum.
The difference between einsum and something like torch.permute is huge. Torch.permute is literally impossible for human brains to parse. Anyone who says they have is lying.
Yes. Well, yeah, I do have the problem that I'm good enough at like bullshit tensor manipulation. I often can get correct code with like the permute and transpose, and it's often faster to write than einops. So I'll sometimes do it, and then this will normally work. And then occasionally, I presume stuff will break in a way that is embarrassing and messy. I have yet to actually have anything break in a way that's that bad, but like this will probably happen to me eventually, and I should stop testing things. I logged the pilot. Oh, wait. This is going to complain to me, isn't it? All right, so I just get Z. All right. Does fancy indexing work the way that I remember fancy indexing working? I think it should. So if I am remembering correctly, this will have shape layer, head, d-head, batch, and context. And I can now do a cursed ass einsum to get this code. I can't actually decide if I think this should go first or second. I'll put this first. Oh, wait, no, crap. The thing I need to do is like offset Z by 1. And I need to offset tokens by 1 the other way. Because that way I get something which is predicting the next token, and I always screw up and forget that I'm trying to predict the next token, and it's an issue. And hopefully this code works.
Why is it 255 instead of 256?
Because I'm predicting the next token. And
right. Okay.
Yeah. That's why I have the like offsetting by 1 code, which it's so easy to forget in a way that fucks everything. Oh, wait, I should be applying layer things. So, oh yeah, have people heard the good word of Command D? It is the best keyboard shortcut.
I have not. Please proselytize.
You just highlight a thing, and you press Command D, and it gets you a cursor on like the next instance of the thing, and you can be like shaped, and it's like renaming a variable for lazy people. I think you can also do Command Shift L to get every copy of the thing, and you can also do Option Command down or up to get something on the next line, and then do dumb shit with like things like option arrow to like get things at the end of the variable. And I spend far too much time fucking around with efficient cursors. But
I'll have to find the
amazing.
Windows equivalent of those things.
Yeah, I've just become convinced that Macs are just acceptable. Anyway.
You might be right. I lost half an interview recently trying to get an environment to work. I got WSL installed, so honestly, that was worth the hour and a quarter.
Wait, sorry, you spent an interview setting up an environment.
Well, it was an assessment, so no one else is actually on the other line. But yes,
all right. This is much more acceptable. It would be
iType
hilarious.
does not work with Windows. It does not have Windows support. I did not know that, and I'm guessing the people at the interview place did not know that either, so I passed that feedback along.
Wait, sorry, PyType does not work?
By default, it is not supported in Windows.
What?
So I had to install WSL to get the tests to run.
Wild. Anyway, this gets me the head direct logic attribution. This should get me, I don't know. Yeah, let's like just stack the attention patterns. And set the, yeah, so this should have shape, batch, head, dest pause, source pause. I feel like half the skill of being a good mech-and-tech researcher is just memorizing crap like that. And, oh wait, no, this will have a layer. And I want to set the boss thing to be 0, because otherwise it will be like, boss is the biggest thing. And this will be boring. Maybe I wanted to say boss is the biggest thing. I don't know. I'll be like Argmax with boss. Layer batch heads. First pause to like probably I should cut off the final token because it's meaningless. And yes, I'm probably violating my don't do stupid overkill, but whatever. Oh, yes, I should also just do this for max. And then there's this stupid thing where anyway, I'm just writing ugly code, don't mind me. So you should observe the beautiful, beautiful glory of Command D. And then I should probably convert the Argmax into the actual value of the token. And yeah, I think what I'm trying to do is take the tokens and extract out what the correct output token is. And I am going to screw up the token algebra if I actually try to do this, because indexing is a bitch. Anyway, all right, I'm going down a rabbit hole. I think that probably what I should go and do is go and take things, and then I think the thing that I want to go and do is go and actually take a case study that I understand, so like induction, and run this all there. So let's say batch size is like 4. Random tokens is like between 1,000 and 2,000, and I don't know if there's a convenient way to make a tensor that is just a single value repeated that is not crap like this.
Can you just set like the first column of the tensor to 0?
Yeah, then it's annoying because it's not quite symmetric, and it doesn't really matter, but it will offend.
Did you say you want a tensor filled with one value, like torch.1s?
No, something filled with like an arbitrary value that I would choose, like torch.4s would be the function I would if I wanted to perform.
I think it's torch.fill.
Ooh, does that work?
And then it's like shape, number.
Ooh,
Yep, torch.full, just looked it up.
it's beautiful. Probably I should have just asked GPT-4. Because GPT-4 knows everything.
It has helped me so much with tensors. Can't even remember how I used to code without it.
Oh wait, no, I just like got really good at tensor algebra before GPT-4 was a thing. Probably this was a massive waste of energy. I should have used GPT-4 forever, but like whatever.
I mean, it's not like before. It's not like you knew that you would just have these machines that help you program things.
Interesting. This is what happens with the Python models, because the tokenizer. So I think what's happened. So this is the token correct log prob, and I think that what's happening is that there are certain tokens that are just like insanely rare. So like, say 16. So token like 17 is going to be, I don't know, this crap. And I think either Pythia has some like hard-coded stuff around spaces because code, or there's just something where it's like, well, okay, this has 16 spaces, but there'll be some tokens that have 17 spaces. These always dominate or something. And thus it never occurs. And thus the model learns, oh, this never occurs, so I can just treat it as like minus 800. And I think a similar thing happens with the glitch tokens, which is like, why are the glitch tokens ridiculous and will never happen? What? That makes no sense.
6 never happens, Neil. This is a known fact.
This is fucking bullshit. Oh, wait, it's because I had length. That now makes much more sense. All right, so this is model. This is... All right, I'm going to attribute this to the NeoX tokenizer has some hard-coded bullshit spaces. And I'm just going to run this through my functions and see if my functions give me something sane. Ooh, Jay, is there an induction heads detector and transformer lens I could use to validate this?
Yes, there is. Wait, hang on. Wait, induction heads. I've got previous token, duplicate, and yes, there is an induction head detector. That's the third one.
Nice. And get induction head detection pattern. Wait, what is sequences?
That's just the prompt.
Yeah, it should automatically generate a prompt, right?
which ones are inductive depends on what tokens you pass in. I'm not just assuming you pass in the repeated string thing. I'm assuming you might pass in a valid string, in which case it needs to actually check for the induction.
Oh, wait. Maybe it wants me to input a single string?
Oh yeah, that's right. I thought Mateus added batching, but maybe not. I know he's making some change. I know he made some changes a while back.
Yes. Sorry,
I didn't
why?
support batching, but I thought he did. It shouldn't be 268 by 268 because you're passing in 256 by 256, right?
Whatever.
I don't know what's up with that.
And consider this a complaint about your announcement contributions.
I should look into that.
All right, so I can just check manually for induction heads. And how does this work? Do I use negatives or positives? I think I do this.
Could you explain the diagonal thing? -1, -2, and -1 to 8?
So the thing that I'm trying to do, why is this sat? Oh, it's because this should get fixed. So the thing that I'm trying to do here is I'm trying to automatically check for whether something is an induction head. What? All right, that looks sus. I'm trying to automatically check for whether something is an induction head, and trying to do this by trying to automatically check whether something is an induction head, and trying to do this by looking at the diagonal lines, because there should just be some diagonal lines that are like looking at the induction token. And the induction token should always be like 127 back from the correct token, because the offset's 128 and it's like offsetting by that. And
Where does that number come from?
because I made the thing length 128. I'm confused by this because it should just be the case that the attention patterns are like 0 above the main diagonal. I have absolutely no clue why it thinks this is non-trivial. What? So, okay. This looks much more sensible. What? How is this 1? So this seems to be telling me that there are some things above the diagonal that are like non-trivially non-zero, which is like not making sense. Like, the fuck? How is this non-zero? I am so confused. If anyone has hypotheses, they are extremely wide. What? What? Is something breaking because the model is just not used to getting a certain input token? Is this a transformer lens bug? All right, I'm currently torn between this actually seems like a weird bug that I should chase down versus YOLO, this probably doesn't matter. And interested if people have takes.
I'm still really confused as to why you're looking at the -10 offset of the diagonal.
Oh, that was just a test to verify that that would be 0, because I was trying to figure out which directions offsets went in. And what I've now found is that it's occasionally non-zero. And I was like, the fuck? And it now looks like, occasionally, the attention pattern above the diagonal is non-zero. And I have no clue why this would happen. And this, like, should just be impossible.
Bug and stack activation?
No, because I've then looked at it in terms of the, like, pattern directly. Cool. And, like, the attention scores are, like, minus 100,000 here, and then minus 116,000 here. And
what's
I'm
on
like,
the x-axis?
This is just position. And this is 0, head 3, destination position 214 attention pattern. I am now being like, what? Possibly there's just some hilarious bug where the way that we apply the mask is we have ignore set to 1e-5. And possibly 1e-5 is too small.
I was confused about this in the transformer implementation. Why isn't it 0?
Sorry, so this goes into a softmax. So the attention scores are query.key for everything, including stuff where the key is after the query. You want to softmax over it, but only before the query, but only on the right segment. And if you do a softmax on the full segment and set to 0 afterwards, this does not achieve what you want. Is it clear that doesn't achieve what you want?
Is it like e to the 0? Is that the softmax formula?
Yeah, sorry. So there's 3 naive things you could do. You could set things that are outside the mask to 0 and then softmax. You could softmax and then set things outside the mask to 0. And you could set things outside the mask to like minus 100,000 and then apply the mask. And then do softmax and then apply the mask. I assert that you're only going to get the correct answer if you set everything outside the mask to like minus infinity and then do the softmax.
Oh, right. Okay. Yep.
Does that make sense?
It's intuitive.
All right.
I was actually confused in the implementation why you used 1e-5 instead of like -inf.
No good reason.
Do you think it's at all possible that the activations are so high that it matters?
That sure looks like what I found here, which is bullshit. My best guess is there's just something ridiculous where, I don't know, key 86.this is just like a really big negative number for some insane reason. And I have no idea why this would happen.
I was also not able to duplicate that weird shape bug with the induction head detector where it became 268 instead. The shape is 256 times 256, exactly as I was expecting it to be. I don't know what's going on there either.
What? I am just going to redo my induction task and just give it like actual natural language text, repeat it. And do an induction test on this. And like that should actually work, goddammit. I will also raise a transformer lens issue, being like, lol, this is insufficient. What the fuck is going on? We should set this to minus infinity. What is the set of tools that are achieving this? Yeah, let's just like actually replicate this. Does this happen? Is this like a query? Is this just like a... No. I have no hypotheses for why it is minus 116,000. Beyond the fact that I guess from the model's perspective, it just doesn't really matter. I guess this is a sane value for things to take on, because it is translation invariant. But also, this is insane. Anyway. Bug reports. Sometimes attention score on real text is less than minus 1.5. Set attention.ignore to minus infinity. Minimal example. I'm just going to assume that since I wrote the library, I can make stupid bug requests that ignore all of the required formatting. This gives attention scores that are minus 116,000 on the correct segment, such that the pattern is uniform across things outside the causal mask. Such a ridiculous bug. Anyway, returning to this, I believe that I want negative offset, which means minus 127. This is, yes, detangenting. This seems to be telling me that all induction heads are in the final layer. And this seems ridiculous. Well, if I put a positive number, it seems to be telling me that things are, that it gives me giving me reasonable numbers. And I'm just going to YOLO and say that these are the reasonable numbers. And I'm now going to go and actually test my functions. And see that they give me coherent things. And yep, just replicating that I get these insane spikes for some reason. All right. So now, if I look at head direct logic attribution, the first thing I want to do is clamp this so that it cannot go below minus 10. Because for all I know, it does. Because the world is bullshit. Yep, let's just clamp that. Let's clamp that between minus and plus 10. And do a heat map of this. And so the thing I'm doing right now is just comparing the direct logic attribution for the next token for each head against the actual scatter plot. And this should tell me something interesting about whether I've successfully got something working. Because, sorry, this should tell me something interesting about whether I've gotten anything coherent, because it will... What? Why is this sad? Oh. I put a function on attention cache that got me the head labels. Anyway, I hope this has illustrated the kind of bullshit you get when doing research. All right. I'm going to tentatively call this a win in that it has successfully found me the induction heads. And I'm now going to go and sanity check the various Argmaxy stuff by verifying that if I in fact go and check this for an induction head, say 30, it that is not one. Yeah. If I go and test it, the head is indeed looking at about what I expect it to be looking at. Yep. So this graph is telling me that this induction head is like basically consistently attending to the thing it's supposed to be attending to, with like a bunch of random spikes, but it's an Argmax, so who cares? And then this graph should hopefully tell me yeah, it's like sharp-ish. Yeah, this is telling me, yeah, this head has pretty sharp attention, mostly, but it's also really noisy. The final thing I might want to test is taking the tokens and taking the Argmax and trying to have it tell me which is the token being looked at. The way I want to do this is by seeing if I remember how torch.gather works, which is going to be totally doomed because I do not remember how torch.gather works. Torch.gather is a magical function that, god damn it. The way that torch.gather works is you have a tensor and you have another tensor of indices along one axis of the first tensor. And no, torch.gather is hard to explain. And also, this approach is not working.
Is it kind of like filtering, but the output can be a matrix rather than a vector?
It's more like you have a vector of like 0, 4, 2, 3. It gets you an output vector of the same size, but where 0 goes to the 0th element, 4 goes to the 4th element along some axis. And you can generally get things to like match up nicely. And no, torch.gather is fucked. It's just also convenient because there is often a like specific thing you want to be doing. I should probably also just stop doing what I'm doing because this is a tangent. All right, I have beautiful code, which I think will get me the predicted token. And the way I can test this is by taking a scatterplot of token 30 and that did not do the thing that I wanted.
I'm gonna have to head off now, but thanks for showing the process live.
Yes. Yeah, don't feel obliged to stick around indefinitely. There's a hackathon happening at Arena, and my current plan is just to head off there whenever you guys get bored. or I get bored and want to have lunch. I'm also curious whether this is like actually useful.
Yes, this is great.
Awesome. Curious what's useful about it beyond seeing how bullshit everything is.
That was my first choice, but
I'll take it.
I think it's just picking things up. Like to pick up velocity, you need to learn like 1,000 little tricks. It's like, oh, don't forget to start from one and finish before one when you're like gathering your inputs and predictions, stuff like that. There's just like so many little things, and the fastest way to pick them up is by example.
I'll take it. All right, this makes sense. So
Also, talking at the start is really useful.
I presume you mean me sending out the project rather than me making small talk?
The small talk is useful. It's at the start, yeah.
I also think it's useful to see how you debug these things because I run into so many problems.
I'm not
Yeah, I like when
confident
you
I'm
route around
good
issues.
at debugging things. Wait, did I successfully route around issues?
Yeah, like switching from the random tokens to the prompt string.
Oh no, I considered doing that and then was like, I didn't give a fuck. I'll just
Yeah, I don't know. It's kind of a mindset that I feel increases your like productivity, not getting stuck going down
yes.
random rabbit holes, or like getting stuck going down productive rabbit holes.
I'll take it. Anyway, I'm currently doing some tokenization bullshit to get me a convert the Argmax to like the tokens that are predicted. Yep. All right. I'm going to declare victory. And what should I even call this section? I'll call this actually running the model on the data distribution. And let's call this prompts, say 256. Batch size equals 32. See if I start getting ooms. Oh, I should do torch.set grad enabled false. This is another bullshit magic trick where a really obnoxious thing about PyTorch is that it uses automatic differentiation, but it also wants you to be able to differentiate anything whenever you want. So if a vector is marked as like, I might want to differentiate, it will keep around everything that is ever computed by that thing in memory, just in case you need to do differentiation. And this is how you get moves. Um, really properly make run with cache something that lets you customize which things get returned. Unless I actually did that, and yet like, oh no, I do have a name set, but also whatever. So things which I want to track are like and yep, that thing. People come across TQDM. It's so great. All right, I now have the beauties of the form, and I should also really comment out all of these. All right, and so, wait, no, this is not what I want it to be. And this is really obnoxious thing where at work I'm using Jax for things because DeepMind, while on these I'm using PyTorch. And Jax and PyTorch are like almost the same, but not quite the same, and they have all kinds of subtle details. It's really obnoxious. Oh, wait, no. This is dumb because now my number of prompts is almost the same as my context, and that's terrible. So let's increase this to like 288. All right, so let's just pick a head, like 30, that I believe to be an induction head, and do a histogram for it. Oh, fuck. Abort, abort, abort. It's so pretty. Not what I want, but it's so pretty.
What is that?
So I put in something with shape batch by position, and Plotly interprets this as like plot a separate histogram for each entry in the input tensor, and they're all stacked on top of each other, and it's really cute. But it also takes ages to plot. There's not what we want.
That's
So
wonderful.
let's.
Gotta keep that one in the back pocket. It's a great aesthetic for visualizations.
Man. Yes. If I did make this a YouTube video, that should just clearly be the thumbnail. Yeah, people think this is about making pretty things rather than debugging transformer lens bullshit. All right. Oh wait, I should set the context length to 256 and actually write this at the top of the script because that's just obviously a thing that should be an important variable. Anyway. Yes. Anyway, I'm now going to actually try to plot a histogram. The histogram does not want to have hovers which actually tell me the value of a thing. That's obnoxious. But god damn it. I'm currently just going into random Plotly BS.
This is the point at which I usually paste it into ChatGPT and say, work out what I want to do and do that instead.
This is possibly just the thing that I should do. I have a thing where I'm just not really in the habit of using ChatGPT for things. Possibly this is dumb, and I should get into the habit of using ChatGPT for things. But also, I strive to be a man of principle. What am I doing? Wait, why does it not think this is a real thing? Oh, sure. I did find it in here. That is a very reasonable thing to complain about. I have a format. Nice. So the thing which I'm trying to do here is just basically just create a histogram that I can plot, and Plotly will not hate me. And where I can easily extract what the biggest things are. What? Oh. That is a reasonable thing to object to. What? Why is this still annoying me? That's 288. 255. Oh. Man, maybe ChatGPT would just do this more efficiently than I would. Yeah. Come on, actually give me a coherent histogram. You know you can do it. Okay. Not quite the thing I was expecting.
Is it moving things to just empty spaces?
So this is following the string Android by colon, which very plausibly is an example of induction. And I set things up so that I could hover over something and just like see what it is. So now I can just go to like batch 88 and token 79 and try to see what's up.
Why is it prompt number out of in context?
Because I wrote it that way. Slash here is just being like, well, I want two numbers that are clearly delineated. Slash is a reasonable character for achieving this and does not mean division. So this is a very reasonable mistake to make. Also, man, my laptop is warped. So I have this head. It has examples of doing something interesting. I now want to actually take those tokens. I guess I want to just first like print the tokens. And then I want to wait, I should really define the head that I'm looking at. Layer. All right. How much sense is my current point in the investigation making?
Makes sense.
I think I'm following the big lines of thought, yeah. The smaller lines of code sometimes not fully.
You don't need to understand all of the bullshit I'm doing with graphs and tokenization. Seems fine. Aha! Okay. This sure looks induction-y. This is very exciting. Yep, getting some very distinctive induction stripes. Also, Plotly is sad at how big my graphs are. But whatever, that's Plotly's problem. Yep, all right. I'm just going to declare this is clearly induction. Another thing which would be good to set up is having nice code to actually plot values and like across tokens and understand the values. Oh, wait, no, circuits viz is kind of a pain. I'm just going to use a function I have to literally plot HTML, which I think I have. So
Yeah, I'm not sure there's a way to install circuit viz at the moment without downgrading your PyTorch to 1.3, which seems to be very annoying.
Yes. We should just send Alan complaints.
I'm not 100% sure. I might have had a PR up for that got closed today.
Ooh,
I closed something of mine.
nice. Well, sure hasn't updated the pip. All right.
Yeah.
If I clear everything, does this make my thing? Yes. All right. This is so much faster. So now I can be like, create HTML model to stir tokens. And now I can be like, okay, when I plotted this histogram, it sure thought that certain things were important. And yeah, so if I look at this, it's like 79, and some things that I would reasonably want to plot would be like, what is the probability the model puts on like predicting the next thing? Okay, sure looks induction-y. I'm also surprised it gets this one right. But yep, that looks pretty induction-y. What else might I want to look at? I have the hypothesis that this head is an induction head. This is not actually the thing that I'm most interested in investigating, because I kind of feel like I already understand induction heads, and I want to understand whether this can be productively thought of as, whether there are heads that can be productively thought of as mover heads that are like not predominantly induction heads. But this seems like a good place to iterate. There are some things that I am kind of curious about. Like if I look at the things where it does terribly, what's happening? So here I've got like 14, 154. And if I look at this one, then what do I get? Oh, lol.
Can you quickly say what doing terribly means in this context? That it's just not an induction head, or that the induction head is not working?
I was looking at like this, where I'm like, okay, that's incredibly negative.
So it's making the output less accurate.
Yes, it's like minus 2.5 from the correct Logits. And I'm like, that's interesting. Why would that happen? Probably it's going to happen because it's doing induction, and it happens to like be screwed over, which does in fact seem to be what's happening here. An interesting question would be, where is it attending from the position that it...
Sorry, I'm confused by the color coding here. Is the pink, what's the pink, orange, purple?
Blue means positive, red means negative. Assuming pink is just like negative. I don't actually know. GPT-4 wrote my color code. Yeah. I don't know, man. I'm just interpreting this as it predicts the wrong thing on name. All right, so what are the other functions I've made that I might want to test? Yeah, so I've got my like big heads DLA thing. I've also got my list of like attention indices. I'll just copy the text over here so it's easy to refer back to. And for these, I should be able to go... All right, so first, I should rename this to what index. And yeah, what was the name? So I have my like attention index list. And let's say I want to get the max attention with boss. And let's figure out what shape this thing has. Oh, so this is telling me what the max attention is. This is telling me what the Argmax thing is. And wait, no. This is completely useless.
What's the second dimension in attention index list? The second.
Oh, that's just like which of these. Really, I should make it a named tuple, but I can't be bothered. I can just remember it. Yeah. If I make this the max attention without the boss token, is attending to something quite a lot of the time. What I would like to do is have a test for whether it is attending to a copy of the token it is predicting. Let's create a like def. Let's just call this mover attention score. Yeah, okay. Scratch my attention summary statistic bullshit, which I think is just confusing. I think what I should instead do is have a cache and tokens, and I hate actual dot strings. Return the average attention paid to copies of the current, copies of the next token. And to do this, I'm going to get the patterns. Oh,
And this is for each head separately.
yes. And yeah. And so here I have like patterns. I can create an is next token mask, which is like, man. So tokens has shape batch by position. I want to have something which is like destination token, batch by destination by source, and the destination should be the next token. The source should be the previous token. So this should be a, for each token, if attends to previous thing be true, patterns should be layer by batch by head. And yeah, let's do an idle reduce on this. So this is like layer, batch, head, desc pause, source pause, comma, batch, desc pause, source pause. And I want to reduce it to layer, head, batch, desc pause, and the reduction should be sum. And I think this should just work. What? Oh. Let's just add a dummy batch access. What? Oh. It is because I am not filtering to only be. What? Oh. This is a reasonable thing to complain about, because this is not an Einstein. Okay. I should probably call this something which is not some variable. And well, sure looks like that sometimes spikes. Why is this sad? Let's get so this has that shape. This has the correct shape. Oh, this has the wrong shape. Okay. This is telling me that the mover score and head DLA are pretty heavy tails, and that there is some amount of like positive correlation, but also it is not perfectly the case that it always has high direct launch attribution whenever it has high mover score. Sometimes it has high mover score and like does terribly, which I presume are the instances of just like name occurs and the model sucks. Yeah. Yep. These three. Where it should clearly be doing induction-y things. I guess we can also have a separate score that is like Argmax mover score. Yeah, we could create a separate metric, which is like take the Argmax, look at what it's looking at, and see if what the sharpest thing is has the same value as the current token. So,
Sharpest being highest attention point?
sorry?
Sharpest?
So when I generally say sharp, what I mean is like a thing which is more like 0 or 1 than a thing which is varying continuously. The thing which I was thinking here is you could just look at the token that is most looked at, that is not the boss token, and check, is the value of that token equal to the current thing? Let's just leave it at this score for now. Observations from this graph. The first observation is that I should clearly also have like HTML for both of these. And so, okay, this is like itty 218. I should tone down the opacity. Nope, that did not do what I wanted. maybe I should increase this to like 0.3. Nice. That. Let's have this be an actual variable so that here I can just set to 3 without fucking up everything else. Okay, so it's like the head is really important for producing itty, which is actually kind of surprising. But yeah, how on earth is it doing that? It's got like a fairly substantial itty score, but it's not induction because I can't see itty occurring anywhere else. And thus this becomes interesting. Yeah, I think I want to spend a bit of time digging into what on earth is going on there, because this is surprising to me. Plausibly, the answer is just, well, heads are doing multiple different things, man. You're not going to get perfectly monosemantic mover heads, and the world is sad. But it's also plausible there's like something interesting, and I'm going to poke around. So the pos index is 217. 217 because this is the next token. Oh, let's call this pos. So the first thing I want to check is just what is the attention? So it's attending strongly to Don, Bill, and patient, which is like the second word after description. Though importantly, it is not the second token after description, which is itself kind of interesting. Huh, yeah, that is okay. So it's a more complex induction head in that it's operating on like word level, which is already pretty interesting. And now I think I want to go and try to do the same thing I was doing with the name mover head, where I'm like, what exactly is the OV circuit of this head doing? And I think the way to do that is to take each of these positions, say, let's just look at the bill one, 109, and there's, okay, so there's two reasonable things to do here. I can take the unembed vec, which is like, oh, I forgot I have an outline pane. This is useful. So I want to see if we've got a function that will nicely give me the unembedding vector for a token, because that would just be a convenient thing to have, and I mildly prefer, I do. Tokens to residual direction. Exactly what I want. And yeah, I also want to take the scale and either multiply or divide by, depending on what the actual thing done in the code is. And you divide by scale, apparently. So this is the unembedding vector. The first thing I want to check is the value decomposition. So I take the value of the head. I take the 0 across all positions. I then take the head. And so this is like a pos by t head thing. Yeah, call this values. Then I take attentions. This is just a pause thing. And I can take the dot product. I can take the product of these two, multiply by this, and multiply by unembed back. And this should give me a thing, which is like what? Oh. So, well, this. Okay, so I initially said this is interesting because it was like spiky at all of the places. The other thing was spiky. But I'm now also observing that, like, I don't know how interesting this is because I am weighting by attention. Now, if I don't weight by attention, it's like much more ambiguous. And it also really, really likes awk. And I have no idea why it likes awk. It also occurs to me that I should really do create HTML. Okay.
This is like indirect evidence of which words get retokenized. Retokenized.
I wouldn't go as far as calling it re or detokenization. The main thing which I want to be investigating, so mathematically, Z is just the weighted sum of values, weighted by attention. We know the head has like high direct logit attribution, and this suggests that, and like, so mathematically, each value contributes to that linearly. Does that statement make sense?
I'm losing focus. Can you repeat it?
So Z is just the sum of attention-weighted values.
Mm-hmm.
Direct logit attribution is Z dotted with the vector of like the itty unembed. And so what this is telling me is that I can make this into a sum over the source position of like how that source position will contribute to the unembed if attended to. And I can also weight it by attention to just decompose how much of the direct logit attribution comes from each previous token. And we see that it's like extremely sharp. So we already knew that it was sharply attending to like specific tokens. And what this is telling me is that like, stuff just kind of works. Like everything it attends to is like boosting the itty. I have no idea why this happens. So a thing which I'm going to go investigate next. All right, how much sense am I making now?
Making more sense now, but I still think I'm going to finish up for the day because I'm definitely fading out.
No worries.
I'm also starting to struggle. And
Yes.
I also
All right.
need to leave anyways because I have peer programming now.
Nice. This is the packed schedules I want to hear about.
Yes.
All right. This was fun. Thanks all.
Yeah. Thanks.
Yeah,
Bye.
thank you.